Introduction to polynomials. Anybody ever heard the term polynomial before? You must have.
I've heard it, but I
Does anybody know what it means? It's what? Okay, polynomial is just a generic term meaning a many-termed expression. They don't really do a great job at defining this. So let's do this. See note number 1. Note number 1. All right. So, polynomials. It's right there. Poly meaning many. Okay? So there's basically, polynomial is just it's name for the number of terms in an expression. Okay? Well, no, poly means any given number, right? And then we have some specific names for certain number of terms. For example, a monomial. What do you think that would be? That's one term. It's a single term expression, okay? For example, 4x, that's a monomial, okay? Single term. You think, well, it's like two things to me, right? No, they're multiplied together. It's like group. It's one single term, okay? Binomial. Mm-hmm. That's two terms. Okay? That might be 3x minus 4. Okay? Two terms. And trinomial. Would be a three-term. Three terms. So like 2x squared minus 7x plus 9. Okay, three terms. And right, like if there are like terms that haven't been combined, they don't count as multiple terms. Like instead of minus 7x, we had minus 5x minus 2x. It doesn't make it a four term, right? You combine those. Okay, you got that? All right. So polynomial, yeah, quadrinomial. After this, they don't really have great names. You just say the number of terms in the polynomial, right? Like a 9-term polynomial. If there are names, I don't care. These are the three main ones. Anyway, let's go back. And they're going to kind of present this in an interesting way, so we can kind of formulate a sense of how polynomials work in the way you're supposed to write them in standard form, okay? So let's start out with something that doesn't quite seem like it relates, but maybe you'll see in a minute. You know powers of 10, right? Like 10 to the first would be equal what? What's 10 to the first equal? What's 10 to the 0 equal? 1, okay. 10 squared is?
100.
10 to the third?
1,000.
1,000, okay. So let's take this number 563, yeah? Isn't that 500 plus 60 plus 3?
Yeah.
Okay. But instead of 500, couldn't we call it 5 times 100?
Yeah.
Right? Plus 6 times 10?
Yeah.
Plus 3, I'm going to say times 1. There. Let's include that. And instead of 100, we could write that as what power of 10? Right? Because there's two zeros, right? So 10 to the second. So 5 times 10 squared plus 6 times 10 to the what power? First. Now how about this 3 times 1? 3 times 10 to the what power? 0, right? So you see how if you do it that way, it's consistent? Okay? 10 squared, 10 to the first, 10 to the 0. Is anything to the 0 power equals what?
1.
3 times 1 is just 3. Okay? So let's try this with 274. So that would be 200 plus what? Plus 70 plus 4. But that's actually 2 times 100 plus 7 times 10 plus 4 times what? Let's make them powers of 10 now. So that equals 2 times what? 10 squared plus 7 times 10 to the plus 4, what? 10 to the 0 power, okay? All right, 3842. Okay. Do we need to write out the
No,
first line anymore? Let's just skip right to the second line.
it's
This would be 3,
10 to.
I better go down below, actually, might run out of room here. You guys might do the same thing. 3 times, well, 1,000 plus 8 times what? 100, yeah. Plus 4 times plus 2 times 1, right? Now let's do powers of 10. 3 times 10 to the what? Third. You getting the idea? Plus 8 times 10 squared plus 4 times 10 to the first plus 2 times 10 to the what? 0, okay? So why don't you guys try D on your own here? Just write them as power. Just go right to, maybe you can just skip right to writing as powers of 10, right to the last line. We don't think
Oh,
we
they
need
have
to.
serrated edges.
Yep. Yes.
Is that what that's called, serrated?
That's
what a knife is.
Yeah.
Serrated.
It's,
Either way. You know,
like, just, yeah, just do this here. So what's this gonna be? 5 times 10 to the third plus what? Yeah, should we put a placeholder in there? Let's put it in there, why not, right? Where plus 0 times 10 squared, isn't it? It's kind of silly to have it there because it's going to end up being 0, but times 8 times 10 to the first, and then what? I should be putting plus there. Sorry, that's plus, and then plus 1 times 10 to the 0. Okay? How about this last one? All right. Well, you probably have it right. 10 to the first. 0, what? Oh, you're on this one, okay. 2 times 10 to the what? 2 times 10 to the fourth plus 10 to the third plus second. Go ahead. Plus. Okay, that's not hard, right? So you can break up any number, you know, like that, right? Even if you get into decimals, right? It'd be times 1/10, and 1/10 squared, and 1/10 to the third, wouldn't it? Anyway. Okay. Well, fast is kind of easy. I guess you got to kind of write it down. Now let's kind of. I'll try to stay out of the way. So now we're going to try to get this into an algebraic expression, like a polynomial, okay? So let's take this number here, 63,735. Let's write it out as quickly as we can, all right? It'd be 6 times 10 to the 4. Go. All right, now take a look at part B. What are they asking us to do?
if x is 0,
Say that again. Read it again.
if x is 10, it's x
X equals 10.
greatest number the times of the.
So if things are equal, what can we do with them? Replace them with one another, right? So all these 10s here are going to get replaced with what? X's. So this will become what then? 6x to the fourth plus 3x to the third. Keep going. generally you don't, but we're gonna keep it up here for consistency's sake. Okay?
And 5x to the 0th power. And then
Plus 5, plus 5x. Let me make that neater. What's that, Tegan?
It's really just plus 5.
It is, but 5x to the 0. I want to stay consistent with this, right? So we start thinking about polynomials and how they work in standard form. Okay?
Would you ever combine those up? Like all have-
Are they like terms?
Yeah.
No, they're not. Like terms have the same variable and the same exponent. So not even kind of. You cannot combine those, Okay, just make sure we're clear on that. You can only combine things that are like terms if they have the same variable with the same exponent, right? Like again, the 7x squared, if it was broken up into 5x squared plus 2x squared, then that combines to 7x squared. Same variable, same exponent, okay? Everybody got that? I see kids do that a lot. All right. So you notice that the exponent, this is a polynomial, right? Now, notice how it's listed with the exponents. What do you notice?
They're cutting down by one.
Yeah, the exponents are written out in descending order, okay? The terms are written in descending order of exponents. Descending means going down, right? Okay. So here's how they express that. Here's polynomial expression. And a rule. We put things in standard form. This is a polynomial, okay? Ax to the nth power, right? And what's 1 power less than n? X to the
Negative
well, what does it say there in the next term? X to the
n minus.
n minus 1, right? And then there's 1 power less than n minus 1, n minus 2, right?
Negative.
Right, so if x is 4, then n minus 1 is 3. And then there's my n minus 2, n minus 3, n minus, right? And all the way down, however many terms you have, right? The first term is always the highest exponent when you write polynomials, okay? You always want to get them written with the highest exponent term down to the lowest exponent term. All right? Now, to be a polynomial, there's a couple things, couple rules it has to comply with here. All the exponents are positive integers, okay? Or basically they're whole numbers, positive numbers, okay? So you cannot have, there will be no x to the negative n power. If there is, we don't call it a polynomial, because what does x to the negative n power actually mean?
Like 0.1.
No, you know it, come on. 1 over 1 over x to the positive n, right? Flip it and make the exponent positive. Okay? So you won't have any negative exponents, okay, or fractional exponents. If it has any of those, it's not a polynomial. Everybody got that? Okay? So, knowing the rules we have to face here. Which of these 4 expressions down here are actually polynomials? Well, number 1, are all the exponents positive integers? 2, 1, and 0? Okay, so this one. What about the second one?
No, because it has a 1 over x, which was a negative.
Yeah, this, right, this is actually 9x squared plus 2x plus x to the, that's the first there, right, to the minus 1. So that violates this part here. So we don't call that a polynomial. What about the third one?
Yeah. No.
Are the exponents all positive integers?
Well, does it say negative? No, it's,
Other-
there is no integers.
Well, the exponents are all variables, so it's not a polynomial. This is exponential, it's not a polynomial.
Yeah, I do that.
Mm-hmm.
I did.
Right? Because we can't determine whether they're positive integers or not. And what about this last one? Is that a polynomial?
Gotta be. No, because it's not negative x.
let's see.
But the
It didn't say none of the terms can be negative.
Yeah, it is, because it has all positive integers.
Yeah, it's the exponents that have to be positive integers, right? So this is also a polynomial.
So,
It's a 4-term polynomial. What's this one called? This first one? Trinomial, right? All right, next page. So let's look at standard polynomial form, okay? So standard polynomial form. It's listed in decreasing order of exponents. Okay? All right, so they want us in exercise 4 to write each one of these in standard form. In part A, is this polynomial written in standard polynomial form?
No.
What's the problem?
Nothing.
Well, to be in standard form, it has to be written in what order?
It would have to be negative 8x plus 7.
So you have to start with the term with the highest exponent and end with the term with the
Lowest.
lowest exponent. So let's rewrite this. So this will equal what? Which term has the highest exponent?
5x.
So 5x to the third. Come on, you guys, what's the next one?
3x squared.
Plus 3x squared
Minus 8x
minus 8x to the first, right?
plus
Plus 7x to the 0, right? All right, you get it? It's that simple. It's just the exponents have to be written in decreasing order. Okay, so how about part B? Is that in standard polynomial form, Wheeler? No? Yeah? It's in decreasing order of exponents?
9x.
Huh? Well, tell me what it should be. Wheeler. Which term has the highest exponent? 9's not one of the terms. There's other stuff with it. It's in your page right in front of you. 9x to the fourth. Go ahead. What should be the next term? What's the next term with the next highest exponent? Yeah, exponent. There's no negative x there. Huh? There's no negative x term. What is that term? That's not an x. What is it? There's a thing on it. What's that 2 mean? What's where? So negative x squared, right? Minus x squared. What's the next term, Wheeler? Plus 2x. And then plus 1, x to the 0. Okay? Hey, Hannah, is part C in standard form? All right. So tell me how to write it in standard form. What's the first term? What should the first term be?
Why do you go 9x, like 4?
To the fourth power.
And then why do you, instead of, I would put 2x instead of.
Why 2x? No, the exponents. Not the number in front of it, the exponents. The number up high. That's not that's an exponent, those guys. Right? So now you know that. Rewrite C for us. Whoa, whoa, whoa. What's that number? Negative what? 5x squared, yep. 2x, yep, to the first, right? Go ahead. Y minus 3.
Oh, it's positive.
Plus 3. Yeah, the sign's in front. Yeah, there you go. Okay? Standard polynomial form. Descending order of exponents.
Okay, that part.
Yes. Okay. Nope. All right, exercise 5. Here's what they want us to do, like we did on the front page, right? Each one of these is powers of 10. So let's do our 523. And we're going to do something else with it. That would be 5 times 10 to what?
The third,
Second. Keep going, everybody. Yep, plus
3 times 10 to the 0.
to the 0, right? Now let's do the 271.
Plus 2 times 10 to the second, plus 2 times 10, or 7 times 10.
Yes, 7. You got me. What in the world? What's going on with this? Uh-oh, we're getting a glitch out here.
First, plus
What's that page?
2 times 10 to the
Oh,
0.
brother. Look at that. Why would it do that to me?
It's because you're old.
It's not, it's this thing. Yeah, I'm old, whatever. 2 times 10 squared plus 7 times 10 to the first plus 1 times 10 to the 0. Now they want us to add these things. And remember, when we're going to add them, we're going to think about combining like terms.
So what if
They'll have the same base with the same exponent will be like terms. So let's do it this way. Huh? Okay.
Question.
Yeah, yeah.
So what if you do the 5 and the 2, because like the exponent, if they're both being
They would be like terms. So we'll line them up like this, right? So let's line them up. So we have 5 times 10 squared plus 2 times 10 to the first plus 3 10 to the 0 plus 2 times 10 squared plus 7 10 to the first plus 1 times 10 to the 0. So I have all the like terms lined up above and below each other, okay? And so if I have 5 10 squareds and I add 2 10 squareds, how many do I have?
7.
7 10 times 10 squared, right? What's the next one? Times 10 to the first plus
Or if it's a 10
times 10 to the 0. What number is that actually?
to 1.
What's the actual 3-digit number?
700.
Yeah. 794. Now, generally, I don't want to add them like this, like we did this vertical thing here, okay?
I feel like this one's a little easier.
Well, you're going to see why it's a problem. I don't want to do it this way. Yeah. Sounds like a what? Well, so now they replace the 10 with x, right? So yeah, let's do it this way real quick. And then I really want to get away from adding like this. So this would be what? Are these like terms? Guys, are x squared and x squared, are they like terms?
Yeah.
Can I combine 2x squared with 7x?
No,
Why not?
because it doesn't have the square at the top.
They're not like terms. So what do we get here? 7x squared plus
Plus 9.
9x plus 4.
That's literally the same thing.
Yeah. So now, here's what I want to do. With this next one in part B, they're different terms here, right? I don't want to add them like this. This is not going to be good for, especially when we go to subtract, okay? So what I want you to do is take this, negative 4x squared plus 9x minus 3 plus this guy, 7x squared minus 5x plus 4. Okay?
Oh, I've done that.
And now we're going to think about combining like terms. So start, what's the highest exponent term in there?
The square.
X squared, right?
Would be 3x squared.
So we have negative 4x squared plus 7x squared, which is what?
3x squared.
Positive 3x squared. Now which terms do we go after? X to the what power?
First,
X to the first. So 9x minus 5x is plus 4x. And now which terms do we go to? X to the what? X to the 0. So negative 3 plus 4 is plus 1. Okay? And it's, you do with that, we start with the highest and go to the lowest terms to combine them, you automatically end up with standard polynomial form. Okay? Now we're going to look at subtracting. And you might see why that this is not going to work very well. And pay very close attention to what we do when we subtract. Okay? I don't want to waste any time with that. Okay? So I'm going to subtract them this way. Yeah, I don't want you to even have to double think it, right? So here's what you're going to do. 6x squared plus 5x plus 3 minus, now here it is. Watching everybody? I have to subtract that whole polynomial. So what do you think I need here? Parentheses. Parentheses. This whole thing. Is that supposed to be? Yeah, that's what I'm talking about. That's why they, yeah, that's a positive too, and they want to subtract like the whole thing. That's why I don't like doing this. That's supposed to be a positive 2x squared minus 4x plus 7. Okay? I have to subtract the entire thing, so I need to subtract it as a group with parentheses. You with me?
Yes.
And now, what am I going to do? What's actually in front of this parentheses? A -1, right? And what am I going to do? I'm going to distribute this -1 to each term in here. So 6x squared plus 5. Technically, I'm subtracting. Isn't there a 1 in front of everything, Tegan? And if I'm subtracting, it's a -1 in front, right? Now, technically, I'd have parentheses around this first group, right? But what would be in front of it if I had parentheses around the first group? A 1. Is it going to make any difference? Okay. 5x plus 3. Go ahead. What do we get?
Plus 2x squared.
Nope. Minus 2x squared plus 4x minus 7. Okay? If you're going to subtract, make sure that you use parentheses and distribute the negative. Everybody's got that, right? Okay. Now let's combine like terms. What's the highest exponent term in there? X squared. So
4x squared
4x squared.
plus 9
5x plus 4x is 9x.
minus 4.
And then 3 minus 7, -4. Okay?
I was gonna skip the first one, I get to know what I was gonna skip that one below and answer dot.
Don't. You'll mess up. You'll make, yeah. You want to get that in there and then distribute so you can clearly see what the actual signs of them are before you combine them, okay? If you try and do it that way, when you get really, really good, like in college, you're taking differential equations, go ahead. Right now, don't skip that, okay? Now, this one here, okay, there's parentheses in front of this one, right? But what's in front of this? And if I distribute that one, is it going to change any of the signs or anything? What's in front of this one? -1. Now I better, like, distribute that. So if we distribute this positive one up here, we get our 4x squared minus 2x plus 7. And, let's see, Hannah, what do we get when we distribute this -1 here? Distribute the -1. -1 times 2x squared, Hannah, or -2x squared. What do I get? What's -1 times -2x squared? What's a negative times a negative? Huh? Positive, what happened to your x squared? Yeah, so say it. Yeah, 2x squared. Keep going. Do the next one. Minus x, yep. Do the last one. We're multiplying. -1 times -3.
-3, I mean 3.
Positive 3. There you go. Negative times negative is positive. Okay, combine like terms, everybody.
6x squared minus 3x plus 10.
2x, yep, minus 3x plus 10. Okay? You with me? Okay, these last two, you're just going to rewrite them in simplest standard form. So you're going to combine like terms and get them in standard polynomial form, highest exponent term to lowest, okay? So you all take a minute and do these. You can look like I do. So notice how I have equal signs all the way down, right? Because I intended to be connected with equal signs. So we want to do these now. You guys get part A yet?
Yeah, kind of. 5x squared plus 6x minus 4.
How many agree with that? So 6x squared minus x squared is 5x squared. And then we got our positive 2x plus 4x, right? And then, I don't know, usually negative 3 and then minus 1, right? The sign that comes before it goes with it, right? So minus 4. Everybody get the last one yet?
5x squared minus 2x minus 2.
Maybe.
I agree. I thought that.
What do you have to do first here, guys?
Distribute the negative.
Distribute this negative, negative 1, right? So we get 6x squared plus 2x minus 3 minus x squared minus 4x plus 1. So now I take my x squareds, and I get 5x squared. Huh? So I get my 2x, did I do that right? Yeah, 2x, okay. There, minus 2x, and then negative 3 plus 1 is minus 2. Okay? You good on these? Before we hit the Regents questions, though. Note number 2. Some stuff we need to clarify that they didn't really touch it. Oops. Okay. So just some terms you need to understand, okay? We've used it before. Coefficient. Anybody know what that is?
No. I'm kidding. I know that that's stuff.
Okay. That's the number that the variable is being multiplied by. That's the number in front of it, okay? It's the number. The variable is multiplied by. Right? It's the number out in front of it. So, for example, five x. What's the coefficient of 5x? How about negative 2y? What's the coefficient? The negative 2, right? And how about what if I just had x? What's the coefficient?
1.
Right? It's a 1 in front of there, right? Okay? So know the coefficient, you know the difference between coefficient and the exponent, right? Let's talk about the degree of a polynomial. Okay? The degree of a polynomial is just the highest exponent in the polynomial. Highest exponent, degree, D-E-G-R-E-E. Highest exponent in the polynomial. Right. Give you an example here. So, for example, let's say I have 3x plus 4. What's the highest exponent in this polynomial? It's 3x to the first, right? So we call this a first degree polynomial. Nope, polynomial. Now, we know these by another term, don't we?
No.
Yeah, we do.
Linear.
Linear, right? Exponent of 1. Try this one. That's not a polynomial, remember? What's the highest exponent in this polynomial?
2.
So this would be a second degree polynomial. You guys remember what we call these? No. Exponent is a variable.
Is it this one?
Starts with a Q.
Quotition? Quadratic?
Quadratic, right? It makes the parabola graph, right? So a second degree polynomial is quadratic. Maybe I have something like this. X to the third plus 2x squared minus 9x plus 7. I don't know. What degree would this one be?
Third.
Third degree, right? Third degree. Anybody know what we call these?
Polynomial.
Cubic.
Cubic.
Yeah.
That's dumb.
Um.
It's 3. Oh, linear, like a line.
Mhm.
Quadratic. 4.
Okay.
Quadratic, like a 3.
Quadratic. How do you find the area of the square? Right.
Length times width.
Length times width, and it's in like inches squared. So 4 sides, right? Quadratic. Square inches.
Yeah.
Hey, what about a solid? Length times width times height. Volume.
3 cubic. Yeah.
Volume is in like cubic feet,
Yes.
right? Cubic. Okay, volume. Yeah. Very woodchucky. All right, now you're going to hear this term, leading coefficient. You know what the coefficients are, right?
Yeah. Is it the leading?
And it's the coefficient on the variable with the highest exponent, right? Coefficient on the variable with highest exponent.
The leading one. Coefficient.
Leading coefficient.
Leading coefficient.
Why would it be leading? Because when you write a polynomial in standard form, your first term is what?
The highest.
The term with the highest exponent, right? And so the variable in front of it would, if it's in a proper form, would be the leading one, right? So if I have, let's say I have 3x squared plus 2x minus 4. What's the LC, leading coefficient?
3.
Because it's on the, right, 3. Let's try this one, right? And it's leading. It's the very first one, right?
Yes.
Okay. So what about this one?
Wait, what is that?
What's the leading coefficient now?
8. This is the highest exponent.
But it's not leading.
But it has the highest exponent. You have to put it in the right form.
Ah, right? If I was to rewrite this in standard form, this would be the first term, leading term, right? So leading coefficient is the one on the variable, the highest exponent. So it's 8 on that third degree polynomial. It's a coefficient on the variable with the highest exponent. What's the highest exponent?
You put
X to the third, right?
You put -2 to the second
Yep,
in front of 8. Okay, he's just
I know.
showing
I did that to demonstrate, right, that the leading coefficient, no matter what, is the coefficient on the variable, the highest exponent. Because when you do go to rewrite this in standard form, this term will be the leading one. Right? You with me on that? Okay? What's the confusion then? You see that? That's the highest exponent, right? The 3? So the 8, by definition, is the leading coefficient, because when you rewrite this, you rewrite it as 8x cubed minus 2x squared minus 4x. Then it's definitely leading, can't you?
We should start the reading question now.
What?
We should start the reading question.
Oh! That's right. God, you've had your teaching degree for 3 years, right? So, yeah, we'll do that. Okay. It's not I feel like I need to give you some more notes just for spite. So now that you have some of these terms, we can look at the Regents questions. Okay? Everybody read over the first one on your own. I don't want you to shout out any answers. I do not want anybody shouting out any answers.
27.
Say what? Asking for the leading coefficient. What's the definition of the leading coefficient, Anna? The number in front. That's what I gave you over here. It's the number of the variables being multiplied by. These numbers in front. Okay? So Anna, what's the answer number 1? Huh?
I think it's 2.
Choice 1, 2, 3, or 4.
I wouldn't go with 1.
So a leading coefficient of 4.
I think it might be.
Okay.
Either 1 or 3.
All right. The leading coefficient goes with the highest exponent. What's the highest exponent here?
4.
That leading coefficient is 3. And what's the degree of this equation, of this polynomial?
I think it's
What's the degree of this first one?
So the
4.
No, the degree is 4.
Oh.
You guys get those straight, okay?
The degree is 3. No, it's 4.
The degree is 4. Degree is the highest exponent of the polynomial.
I thought the leading coefficient was 4.
Four.
No, he's trying to, in like the answer for number 1, in the leading coefficient is 4.
I'm illustrating that number 1 does not match this. So it's choice 4, right? What's the highest exponent term in here? Well, that to the third power, right? And the number in front of it, that's the leading coefficient of 4. And what's the degree of this? 3.
Okay.
Okay? It's not written in polynomial form, right? It's not in standard form. Okay? Okay. On to number 2. Right over number 2. So, Terry has taken this here and written it in standard form, decreasing order of exponent. Well, that's a 1, 7. Are these exponents decreasing in order?
No.
Which one's correct then?
And.
Serenity.
In order. And.
Why?
Because it goes from 7 to
Serenity.
7. That's right.
Right? They are in decreasing order of exponent. What's the degree of that polynomial, by the way?
7.
7. What's the leading coefficient?
7.
It's also 7, right? Okay, so it's and. And by the way, that, like, even though there's exponents that are skipped, it's yeah. But I mean, we could write them with like these placeholders that have no value. So how about 7? Let's just rewrite it for kicks. All right? 7x to the 7th. And how many x to the 6th are there?
0.
0 x to the 6th, right? plus 6x to the 5th. How many x to the 4ths are there? Plus 0x to the 4th minus 3x to the 3rd. How many x squareds?
0.
0x squareds, right? Plus 8x to the 1st. How many x to the 0s are there? 0x to the 0. I mean, that's kind of absurd, right? But technically, you could rewrite it with those placeholders in there. And I think if they, in algebra 2, if they still do the polynomial division, you'll have to do that. But anyway. That didn't have a whole lot to do with this problem. I just wanted to illustrate it to you. All right, on the last one. Read it carefully. Huh? Oh, I wasn't really, that wasn't part of it. You understand why it's and, right? Okay.
Okay.
Well, I prefer if you K. Hannah,
3, 2 and 3.
why?
If the 5 is like greater. 2x5 is like greater than the 2x2 or whatever, and then plus.
2x to the 5th
Yeah.
power, yeah. Goes 5, then down to 2, then down to what? 1, so that one. And that's 3, x, then x to the 1st, and then this is really x to the 0, right? Yeah. What's wrong with the first one?
They're not in order.
4 to 1, then back up to 2, and then down to 0 again, right? So there you go. So it was choice 3. Okay? Just a lot of definitional stuff here. Huh?
Oh, this is. Yeah, but she said because
Oh,
it's
yeah.
3 terms.
Oh.
This is the problem. Yeah, what in the world? Boy, she was sleeping for the lesson, huh? Okay.